This is Teacher William taking you through application of logarithms in real life, and in particular we are going to look at sound intensity, and that's what we call the decibel scale. So straight away we shall first need to understand what is sound. Sound is a form of energy that travels in waves. The loudness of sound depends on its intensity. So the units for sound intensity here are watts per meter squared. Humans can hear a wide range of intensities, so we use a logarithmic scale called decibel scale to express this intensity so that it can be meaningful. So right away we are going to look at we're going to first of all define some terms which we need to understand as far as light intensity is concerned. Now let us first start by looking at what we call the threshold of hearing. Now this is the faintest sound the human ear can detect. It is called the threshold of hearing. Now the threshold of hearing is denoted as I naught equals to 10 power negative 12 watts per meter squared. Now this is the reference intensity. Now whatever I want to calculate any sound intensity, even if it is the head teacher's communication, especially when we have assemblies, we shall always refer to the faintest sound, which we call the threshold of hearing. Now decibel scale is a logarithmic scale that compresses large difference in sound intensity into smaller manageable numbers. Now instead of writing trillions of watts per meter squared, we use decibel. Now the sound level in decibel is given by the formula below. We shall have L equals to 10 log of I over I naught base 10. So that is an expression in decibel. That's what will help us convert watts per meter squared into decibel. So as we move on, we shall realize that where L represents sound intensity, sound level in decibel, which is the dB, I intensity of the sound, I naught threshold of hearing, which we denoted later. This one is a reference intensity, and we cannot change it. Examples of sound intensities. Now these ones are in watts per meter squared. Now you look at a whisper. It's a little bit very funny when you write them in watts per meter squared. So the only way, we first convert them to decibel so that it can easily be read. Normal conversation is that, local constant is that. So let us see how we can convert those ones in decibel. Now they are telling us that a whisper is we want to see how a whisper is converted to decibel. Now a whisper is this one here. We want to see how it's converted to decibel. Now from L equals to 10 log of I over I naught base 10, this we shall have L equals to 10 log of, this is now 10 power negative 10 power negative 10 over 10 power negative 12, which is the reference sound intensity. This is negative 12. So we shall have L equals to, let us first extend, L equals to 10 log of 10 negative 10, then we take this one up plus 12. So our L is going to be 10 log of 10, this is base 10 power 2. So we shall have log equals to 10 log of 10 power 2 10, where we shall have this, we drop here, shall now have 10 times 2. So L equals to 20 decibels. So that is what we call a whisper. It is now converted into decibels, as we can see in our table below. So let me show you the table. Our table is here, having sound intensities in decibels. So we are even seeing the normal conversation. The normal conversation here was this. The normal conversation here is this one. Let us see how we can convert it in decibels. Let us see how we can convert the normal conversation in decibels. Let us see how we can convert the normal conversation in decibels without affecting anything. Now, normal conversation, they are telling us that it is 60. So let us see how we can convert to decibels. Now we said normal conversation. At first they gave us it was is equal to 10 power negative 6 watts per meter squared. Shall say from L equals to 10 log of I over I naught, but equals to 10 log of I, which is 10 power negative 6 over the reference one, the threshold. We shall now have it as the L equals to 10 log, this is base 10, shall now have 10 power 6 plus 12. L equals to 10 log of, this is now 10 power 6. So L equals to 10 log of 10 power 6 base 10. So what shall we get? We shall have 10 times 6. L now gives us 60 dB. So that's what we call the normal conversation. And it is also the same as we are seeing in our video, in our table. That is the normal conversation. So we shall continue like that. Busy road, school bell, music concert, pain threshold. So we shall continue like that as we identify them. So what do we call the pain threshold? Is a minimum sound level at which a person begins to feel pain in the ears. Not just hear the sound, but he feels the pain in the ears. So I've been using W stroke M squared. This means watts per square meters. How much sound power passes through each square meter. So we have some examples here which you are supposed to look at. Number one, find the decibel level given I equals to that. So that is the calculation as we saw it earlier. We have number two also. You can pause the video if you want to calculate. We have another example there. Find the intensity given L equals to that. So this time round they have given us the intensity in decibel. So we want to find, they have given us the magnitude of sound in decibel. So they want us to find the intensity. So that one also is clearly given there. So we have our group work. Group work is there. Here is the task for the group work. Here is the task for the group work. Here is the task for the group work. There we have another item here. There's another one here. There's another one there. There's another one there. There's another one here. That is its task. We have another one here. We have its task here. We have our last question here, and we have another one here. So don't forget to attempt those items, then you notify me. Thank you for watching. Thank you for listening. Don't forget to subscribe, like, and share so that you can be able to find interesting videos like this. Thank you so much for watching. I sign out.